Ladies and gentlemen, a lot of you wanted a video on this worksheet 10.3 WSP 1 through 15 odd. I'm not going to do all of them, I'm going to do some of them. Now, in order for us to be successful, we need to know this information, particularly the information of geometric rules, right? The geometric a sub nth rule, a sub n equals the first term on your list times the common ratio, normally written in parentheses, to the power of n minus 1. And there's also the summation formulas for a geometric series. Now, the summation formula, there's actually two of them. There's this one right here that's great when you have your first term on your list and the common ratio. And this one's even better if you have the first term on your list, the last term on your list, and the common ratio. Now, why do I say this one's even better? Because on this one, if you have your first term right here and your common ratio right there, you're going to have to factor out that a sub 1 term. You're going to have to factor in order to proceed with this formula. So this one's better. If you have your first term, your last term, and the common ratio, just plug it all in, do the math, and you'll be able to get the summation for any geometric series. So let's go to the worksheet. Number one, they give you your first term on your list, they give you the common ratio, and they even give you n. So with that information, we could take a look at our homework here, or at our notes here, and they give us, they want a sub n, so we could use the a sub nth rule for the geometric sequence. A sub n, we don't know, a sub 1 is 5, r is 3, and n is 6. You just do that simple math, and you have your answer. Let's write down, and again, this is the geometric a sub nth rule. So let's write the geometric a sub nth rule. A sub n equals a sub 1 times your common ratio r to the n minus 1 power. So they're asking for a sub n. A sub n will be a sub 1, which is 5, times your common ratio r. Common ratio r is 3. To the n minus 1 power. They're telling you that n is 6, so it's to the 6 minus 1 power. So you could use a calculator if you'd like. All you do is write 5 times, but right here you really have 3 to the 5th power. And of course, in PEMDAS, what do you do first? Multiply or exponents? Obviously, exponents, so do 3 to the 5th. That would be 243. So what we have here is 5 times 243, which is, the answer is 1,215. Okay, so there's your answer, 2,115. That is the a sub nth term, okay? Let's take a look at number 5, for example. Let's see what they give us, and let's plug it all into the geometric a sub nth rule. So what is the geometric a sub nth rule? A sub n equals a sub 1, your first term, times the common ratio r to the n minus 1 power. So let's plug in what they give us to find out what we need. So obviously, to be able to find the a sub nth term, which is what they want the first term, which they don't give us. They want the common ratio, which we could easily find by simply taking a number and putting it over the previous. 24 over 48. That means that your common ratio will be 1/2. That reduces down to 1/2. So how about the a sub 1 term? The a sub 1 term is the first number on your list, which happens to be 96. So what we have here is a sub n equaling 96 times the common ratio, which is 1/2 to the power of n minus 1. This right here, guys, is the machine that produces this list right here. Believe it or not, if I were to plug in a 1, a sub 1, that would give me my first term, 96. Check it out, 1 minus 1 is 0, 1/2 to the 0 power, anything to the 0 power is 1, and 96 times 1 is that first term, 96. If I plug in a 2 right here, that would be 2 take away 1, which is 1. You'd have 96 times 1/2 to the 1 power. So that's really 96 times half, which is half of 96, which is 48. So on and so on. If you want the third term, you could plug in 3. That'll give you 24 as an answer. This is the machine that produces that list, and they want the a sub nth term, which in this case is a sub 12. They want you to find the a sub 12 term, which would be the last term on this list, I guess. So we would plug in a 12 right here and work it out. So we would have 96 times 1/2 to the 12 minus 1 power. And of course, this is a sub 12. And we figure this out by plugging in a 12 where the n is at. So what we really have is 96 times 1/2 to the 11th power. And let's work this out with the calculator. We would get 1 over 2048. Of course, I did that with the calculator. So far I have a sub n equals, or actually not a sub n, we have a sub 12. A sub 12 equals 96 times 1 over 2048. So I could multiply the 96 times the 1 up here and the 1 times 2048, giving us our final a sub 12 term of 96 over 2048. Now that is a fraction and it could be reduced. So I just hit pause and I figured out what it could be reduced by with the calculator. That would be the number 32. So if you reduce both top and bottom by 32, you're going to get your final answer, which is 3 over 64. And you can't reduce that anymore. So a sub 12 equals 3 over 64. I'll be honest with you, this question may throw you off because the instructions say find a sub n, which is usually referring to the last term. And right here they're telling you a sub 12. So they're telling you that a sub 12 is the a sub n term, the 12th term on this list. So if you found the common ratio, which was 1/2, 96 divided by half is 48. That's the second term. Not divided by half, I'm sorry. 96 times half. Half of 96 is 48, that's the second term. Half of that's 24. Third term, half of that's 12, half of that's 6, half of that's 3, half of that's 3 over 2, half of that's 3 over 4, half of that's 3 over 8, and you keep going till you get to your 12th number on your list, and that will be 3 over 64. Let's continue to explain some other ones. Now right here it says write an equation for the nth term. All right, so this is where we want the machine that produces the list. They don't just want the a sub nth term, especially because this one says ... That means it continues forever. So they want the machine that produces this geometric sequence. And again, we're going to have to go to our notes right here. And here is the a sub nth rule for a geometric sequence. All you need is your a sub 1 term, which you could clearly see as 1. You need a common ratio, which you could clearly find out by going 16 divided by 4. That's 4. The common ratio is 4. Or 4 divided by 1. That's also the common ratio, 4. Then you could plug it in, a sub 1, plug in the r, and you'll have your a sub nth rule. You don't even have to simplify. It's very easy, very straightforward. So let's write this down. A sub n equals a sub 1. That's the number 1, right? A sub 1 is this first number on your list, so we're going to put a 1 right here, times the common ratio. So what is the common ratio? If you take a number and divide it by the previous number, r will equal 16 divided by 4, which means r equals 4. Okay, so in here we have a 4, and it is to the n minus 1 power. Believe it or not, we are done. This is the machine that produces this list. Now, why is this convenient? Because if I asked you find the 10th term on the list, I mean, yeah, you could go 1 times that common ratio 4, times 4 gives you 16, times 4, times 4, times 4. You could do that 10 times, or you could just simply say, if you want a sub 10, this is the machine that'll give you this list. You could plug in a 10 right here. 10 minus 1 is 9, and do the math. 4 to the 9th power, that'll give you the 10th number on this list. Now let's say you weren't too sure about this. Yeah, on the PDFs that I give you, you could check your answers on the answer sheet, but let's say you didn't have the answer sheet. Let's say you were taking a quiz and you weren't too sure about this. What could you do? You could plug in the number 1 and see if it gives you your first number. Or you could plug in the number 3 and see if it gives you this third number, 16. So if you did plug in a 3 right here, 3 minus 1 is 2, 4 times, or 4 to the second power, it's 16. 16 times 1 is that third number, 16. So as you can see, this is the correct a sub nth rule. That's what we're doing on this section of the homework where it says write an equation, right? It says write an equation for the nth term. So that's why we're writing the a sub nth rule, the equation that'll give you any number you want, a sub n. Let's go to number 13 here. Now right here, they want us to find the summation, and here's the function machine that produces the list. If I wanted to, I could create my list. Now, what kind of list do I have? They do not want you to begin at 1. They want you to begin at 3. Now, there's a big difference if you're doing 13 compared to 14. You see, 14 says you want the summation from the first number to the 8th number, and you find that first number by plugging in 1 right in here, and that would be your first number on your list. How many numbers would you actually have on the list? Well, since it's from plugging in 1 all the way to plugging in 8, there's obviously 8 numbers on your list. So n would equal 8 in this case. But on number 13, and we are doing the odd ones, if we think about how many numbers are actually on this list, you got to do 10 take away 3 plus 1. 10 take away 3 is 7, and 7 plus 1 is 8. Okay? Now, that makes total sense. If I gave you a homework assignment and I told you to do questions 3 through 10, how many actual problems are you doing? It's not 7, because you got to include the 3. 3, 4, 5, 6, 7, 8, 9, 10. That's actually 10 take away 3, which is 7 plus 1. So you're actually doing a total of 8 questions. So I hope that makes sense to you guys. If there was a 1 right here, yeah, there's going to be a total of 10 questions, but there's not a 1, it's a 3, and you're including that input of 3 as your first number on your list. So you really have a total of 8 numbers on your series right here. So we have an n. Do we have an a sub 1, which is the first number on your list? We could find that first number by simply plugging in the 3. That'll give us our first number on our list. So let's do that. We're going to have a negative 4 times negative 2 to the power of 3 minus 1. So that's really a negative 4 times negative 2 to the power of 2. And we do know that negative 2 squared, that's going to be a positive 4. So what we really have is negative 4 times positive 4, giving us a negative 16. And that is our first number. Our first number is negative 16. You could call it a sub 1 if you want. I'm just writing it out. The first number is negative 16. Now, they want us to find the sum. Okay, so let's go back to our notes. So, sorry about that. For you to use the summation formula, you need your first term, a sub 1, and you need your a sub nth term, your last term on your list. Then you could plug it into this. So, with that said, we already know our first term is negative 16. We want our last term, which would be plugging in this last number, 10. That'll give us our a sub nth term, our last term of our list. So let's do that. Let's plug in a 10 right here. And if I plug in a 10, that's going to be, let me put a line here. That's going to be negative 4 times negative 2 to the 10 minus 1 power, which will be negative 4 times negative 2 to the 9th power. So the question is, what is negative 2 to the 9th power?
I'm on it. Negative 2 raised to the 9th power is negative 512.
There you go. Siri helped us out. So what we really have here is negative 4 times negative 512, and a negative times a negative is a positive, giving us a final answer of 2048. Okay, so that's our last term, all right? That's plugging in the 10. So our last number is 2048. Okay, so now we have all the information that we need. We have S sub n, and that's what we want to do. We want to find the sum, right? So we have S sub, how many terms are actually on the list? We said that there was 8 terms. And how do we figure that out? 10 take away 3 plus 1. There's 8 numbers on this series. Okay, now what is our first number on the list? Our first number is negative 16. So what we have here is S sub 8. We're going to sum up all these 8 numbers on this list. And up on the numerator, we have A sub 1, which we said was negative 16. And we figured that out by simply plugging in this first input that they want us to do. Plugged it in, worked it out. We got a negative 16. And then we have minus A sub n, the last number on our list, which would be plugging in a 10, and we got 2048 for that. So let's write that 2048 with the minus sign first, right? There's a minus sign on the formula, so let's put that minus sign, and then we'll put the 2048. And we still need to multiply the A sub n times a common ratio r, which we could clearly see that the common ratio r is the base of our exponential situation right there. So the common ratio r is negative 2. Now you're probably thinking, wait, how did we find out that r is negative 2? What is, again, to review, what is the a sub nth rule of a geometric series? It's a sub 1 times r to the n minus 1. And you could clearly see that this is in the form of the a sub nth rule. Your a sub 1 term is negative 4 if and only if you start at 1, from 1 to 10, but it's from 3 to 10. So your first term's actually different. You got to plug in 3, we got a negative 16. But your common ratio will be this number that's inside the parentheses. That's really the base of the exponent situation. So we still need to multiply the 2048, multiply it by that common ratio negative 2. And it is over 1 minus the common ratio, again, negative 2. So let's do the math here. On the denominator, 1 minus a negative 2, that becomes plus plus. You're going to end up with a denominator of 3. But before we, actually, why not? We have a denominator of 3. Now on the numerator, let's figure this out. What's 2048, or actually let's call it a negative 2048 times a negative 2. We will get a positive 4,096. And of course we're going to bring down the minus 16 right in front of it. And when you actually do negative 16 plus 4,096, you will end up with 4,080 divided by 3. So our answer, sorry, running out of space here, 4,080 divided by 3 is, the answer would be 1,360. So ladies and gentlemen, the summation of the 8 numbers on this list using the formula gives us 1,360. Okay. If I wanted to, I don't recommend it, but if I wanted to, I could actually create this list right here by plugging in a 3, working it out. I'd get negative 16, and then I could plug in a 4, working it all out. It'd give me the next number, the second number on the list. Plug in the next number and the next number, all the way till you plug in 10, giving you all 8 numbers on your list, and then you could add them up, and it will actually be 1,360. That's why we have formulas, to save us from all that work. So we got 13 down. 15 is exactly the same as 13. Hopefully you guys are able to do that. Let's look at the last section. It says find the a sub 1 term. Find the first number on your list where they actually give you the summation answer. Okay, so since you guys had to do the odd ones, I will do 19, and then you could go back and try to do 17 on your own. So number 19, we're obviously going to use the S sub n formula, and it would be nice if we had an a sub 1 up here, but we don't. So like always in math, let's plug in what they give us to find out what we need, all right? And in order to find the a sub 1 term, we're going to have to plug in everything and then solve for a sub 1. So let's do that. S sub n, which is a summation of this many numbers, we know that the final answer will be 4,860. S sub n is 4,860. So let's put the 4,860 right here. So we will have 4,860 equals the fraction a sub 1, which we don't know the first term, that's what we're actually trying to solve, minus a sub n, and we said, or they give us a sub n being that value right there. Plug in this 3,280.5 right here, 3,280.5, But don't forget about the r that we need to multiply by, right? It says times r. So let's put times the r, and you could clearly see that r is 3, so put a 3 right there. And that's on the numerator. And in the denominator, we have 1 minus that common ratio, which again is 3. So with the calculator, let's rewrite what we have so far. 4,860 equals, we don't know a sub 1. We do have minus, but I am going to multiply the 3,280.5 times 3. That would give us 9,841.5. And it's still going to be divided by 1 minus 3, which happens to be -2. So here's our equation. We will now be able to solve for a sub 1. Let's get rid of that -2 by multiplying by -2. That will cancel. What I do to one side, I do to the other side. So I need to multiply this side over here by -2. That'll give us -9,720 equals a sub 1 minus 9,841.5. So you want to solve for a sub 1, get rid of the -9,841.5 by adding it to both sides. And that would give us the final answer, a sub 1 equals 121.5. So the first term on our list is 121.5. And I should probably write an a sub 1 right in front of that. And you know what, guys? I just realized that I didn't assign number 19 for homework, which means I just did a bunch of work for nothing. Not for nothing, I mean, that was fun, right? Yeah. So we said stop on 15, so you didn't really need that last explanation right there. All you needed to do was 1 through 15 odd, and you have one example of each right there. You guys should be able to do the other odd ones right there. It's not much to do. We will have a quiz on quizzes, and I'll tell you what, I didn't assign number 19 or this last section because I did not ask those types of questions on the quizzes. It's more like these up here, and also from your previous worksheets. So please make sure you do this, make sure you understand it, and hopefully tomorrow you'll do well on that quiz 10.1 to 10.3 on quizzes that I will assign.